Hey guys, welcome back. Mr. Marone here. I'm just going to do a quick lesson on symmetry in figures. It's something you guys have seen in the past. It should be fairly common for you guys to see, so I just want to touch briefly on symmetry. So we've got three different types of symmetry that we're going to look at. The first one's line symmetry, and you see that it says that if a figure has line symmetry, then that means that we can cause a reflection on a line and it will still have symmetry. So if we were to look at this figure here, since I could draw a line straight down the middle, or maybe close to it, right there, we'll go with that third line. If I were to flip this figure over that line, or fold it at that line, the figure would be cut straight in half. Okay, so that would be considered line symmetry. Now, point symmetry means that we can rotate it 180 degrees around a center point, which I'm going to go with right here. Okay, and if I were to spin that 180 degrees, I would have the same figure. It looks the same upside down as it does right side up. Okay, and our third type is rotational symmetry. And if I can take a figure and turn it less than 360 degrees without causing the same thing to happen, then I have rotational symmetry. And a figure can have more than one of those. So in this case, because it's got 8 different little triangles sticking out, we could rotate this a little bit and still have the same figure over and over and over again. This also has line symmetry through the middle, right here. It has line symmetry here, here, and there. Okay, so there's actually 4 pieces of line symmetry on top of rotational symmetry, and it also has point symmetry in the middle. Okay, so we've got a bunch of different options here that we can use in order to assess symmetry. So you have a bunch of practice problems on that page. I just want to look at the first 4. Okay, so take a look at these. And looking at our first figure, we've got our rotational symmetry. If I were to put a point in the middle, okay, I could spin this 180 degrees and we would then have our point symmetry. If I were to rotate it less than 360 degrees, I would still have the same figure, and I can draw in a line here, there, 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 and there, and I have 6 lines of symmetry. So if we were to look over at this, we've got line symmetry, we've got point symmetry, and we've got rotational symmetry in this figure. Okay. Looking at this one, the same thing. I can draw in line symmetry through the middle of each vertex. Those lines are not very good. I apologize for that, but we do have line symmetry. If I were to put a point in the middle, we could rotate this using point symmetry. And if I rotate it less than 360 degrees, rotational would work. Okay. With our parallelogram here, it doesn't appear that we have any line symmetry. If I were to be able to rotate this 360 degrees or less, I would still have point symmetry and rotational symmetry. I could spin it around this point and still get the same figure. And if we look at our right triangle here, I can't split it in half with any lines. I don't think I can rotate it, and definitely not rotational symmetry less than 360 degrees. So this one has no symmetry. So on those figures the rest of the way down, consider what I did. Obviously, you're going to draw better lines. My pen tablet is not cooperating today, so you'll have to excuse the bad lines. And overall, your goal is to see if you can pinpoint how many different types of symmetry are in here. Some of them, as you can see, have many. Others might only have one, and some will have none. So think about that as you go through this. Good luck, and I'll see you tomorrow in class.